Let us start nitro compounds. Preparation of nitro compounds we will see. In the preparation of nitro compounds, first one will take alkyl halide will take plus silver nitrate in the presence of alcohol. In the presence of alcohol, what is the compound we are getting? In the sense nitro compound we are getting, this is to the percentage of 68 percentage, and another one is nitrite we are getting, it is alkyl nitrite we are getting. This is how much percentage? In the sense roughly 20 percentage we are getting, roughly 20 percentage. So alkyl halide we have taken. This is R is aliphatic. This R is aliphatic. This is not aryl. It is not aryl. This in the place of R, aryl should not be there. Aliphatic can be there. Or alkyl can be there. Or alkyl can be there. That means aliphatic in the sense CH3I example. Aryl in the sense iodobenzene, or alkyl in the sense benzyl iodide. Example we said. Now, which can be present? Which can be present means this is possible. This reaction possible for alkyl halide, and this reaction is not possible for this one, phenyl iodide. Iodobenzene, if we take, not possible. For aryl halide it is not possible. Or alkyl halide, that means benzyl halide, it is possible. Sir, next we will see this AgNO2 is a reagent we have taken. Alcohol is the solvent. Alcohol we have taken as a solvent. AgNO2 is a reagent. The compound is a nitro compound. It is a nitro compound. This nitro compound is obtained as major proportion. This nitrate compound is obtained as a minor proportion. Why is it so? That we will see. Now we will see AgNO2. How AgNO2 is there? In the sense AgONO, like this is there. It is AgNO2. AgNO2 is like this. Now we will take this, suppose methyl iodide we will take. Ri is methyl iodide we will take. Now how the reaction is possible? In the sense this lone pair is attacking this carbon, this bond is shifting to high, therefore we will get when this lone pair is shifting, what happens means when this lone pair is shifting, it is getting shortage, it is getting deficient of electrons, so that what happens means this bond is migrating to this place. So what we will get? We will see this CH3, that N double bond O is there, and here what is there means it becomes dative bond O. This becomes what means dative bond O, that like that it will become dative bond O. Okay, actually it becomes what means O minus. It becomes what? In the sense O minus it will become. Sir, that we will see. So now what happens means this nitrogen is donating lone pair and making bond with this, and here what is there means O minus is there. O minus is there. Nitrogen is having positive charge because it made bond with the carbon. Sorry, this I minus is leaving. Here Ag plus is leaving, so that AgI is leaving. Now like this is there. This O minus is having how many electrons? Means its valency shell is having 6 electrons because 6th group. Due to minus charge, 1 more electron, 7 electrons. Like this present. This plus minus means this plus minus in the sense we can like this. Sorry, okay. Like this here this nitrogen is having positive charge, this oxygen is having negative charge. This is called what? In the sense nitromethane. This is called nitromethane. Okay, so we got nitromethane, we got, that's what this. So if alkyl iodide reacting with AgNO2, we will get a nitroalkane. So we will talk about another thing, this alkyl nitrate we will talk. We will talk about alkyl nitrate. Okay, so now we will take this CH3I, this CH3I will take, this AgNO2 will take, this AgNO2. Okay, if this oxygen is attacking, if this oxygen is attacking this carbon, then this I will leave, this bond will migrate like this. This bond will migrate towards oxygen because it is making a bond. So what is leaving in the sense AgI is leaving. So what we will get in the sense CH3 and ONO. Okay, this O is having two lone pairs. This nitrogen is having one lone pair. Here one lone pair is involving in the bonding. This bonding is converting into lone pair. So regarding number of lone pairs, no change. We got like this. It is called methyl nitrite. Like this we got. Okay, so alkyl nitrite we got like this. Alkyl nitrite. So alkyl nitrate we are getting in the sense alkyl nitrate we are getting as minor, nitroalkane we are getting as major. Why is it so? That we'll see. Now, to get nitroalkane, nitrogen acting as a nucleophile. To get nitrite, oxygen is acting as a nucleophile, sir, which is having higher tendency to act as nucleophile out of nitrogen and oxygen. We'll see. One reason, nitrogen is having low electronegativity, oxygen is having high electronegativity. Therefore, this nucleophilicity is more, this nucleophilicity is less. It is one reason. Another reason we'll see here. This oxygen is having more electronegativity when compared to silver. Here also oxygen is having more electronegativity when compared to silver. So bond is migrating towards oxygen here. Here also bond is migrating towards oxygen. Sir, okay. So both cases same. Sir. Next case we will see, if nitrogen is acting as a nucleophile, here nitrogen is getting deficiency. Due to deficiency, this nitrogen is pulling this bond. So this oxygen is getting more electronegativity when compared to this oxygen. Therefore, it is pulling this bond with higher tendency when compared to this oxygen. Therefore, this nitrogen is having more nucleophilicity. This it is having more nucleophilicity when compared to this oxygen, we can say. Sir. Next point we will see. Next point is what means this AgO bond is a covalent bond. This AgO bond is what means covalent bond. It is not ionic bond. Because of this covalent bond, shifting of this bond towards oxygen is difficult. Shifting of this bond towards oxygen is difficult. In both cases, AgO bond is covalent bond. So shifting of this bond towards oxygen is difficult in both cases. But this nitrogen is acted as nucleophile, so it is getting electron deficiency, so it is getting positive charge, so it is pulling this bond, so this oxygen gets higher electronegativity when compared to this oxygen. Therefore, shifting of this covalent bond towards oxygen is more here when compared to this. Therefore, nitrogen nucleophilicity is more when compared to oxygen nucleophilicity, that we can explain. So that nitrogen is having higher tendency to attack carbon when compared to oxygen. Therefore, nitroalkane is major product when compared to this alkyl nitrite. So, now this is coming under which category in the sense it is nucleophilic substitution, because leaving group is I minus and nucleophile is substituting at the carbon in the place of iodine. Okay, iodine is leaving, nucleophile is attacking. Therefore, it is nucleophilic substitution reaction. Sir. So now this why this is major product, why this is minor product, we got an idea. In this, in order to get this product, nitrogen is acting as a donor site. In order to get this product, oxygen is acting as a donor site, and this is major and it is minor. Okay. Now alkyl halide is undergoing nucleophilic substitution, we said. What about this? Now we will take this benzyl iodide. This benzyl iodide, will it go for nucleophilic substitution? Means yes, whereas phenyl iodide is not going. So why is it so? We'll see. Now we will take this iodobenzene, plus AgNO2. Solvent is alcohol. What is the product in the sense no reaction? So here reaction is not taking place. So that means this iodobenzene is not going for nucleophilic substitution. this iodobenzene, this aryl halide is not going for nucleophilic substitution. Okay, why is it? So we will see. Now we will take this iodobenzene, will take this iodobenzene we have taken. This iodine is having 3 lone pairs. So here what is happening in the sense, this lone pair is shifting towards this carbon, this bond is shifting to this place. That means resonance. When resonance is possible? If conjugation is there. So resonance is possible when? If conjugation is present. Conjugation means between what? Between unsaturation. Between unsaturation, between double bonds, between double bond and triple bond. Okay. That means if two double bonds are separated by a single bond, then we can say this double bond is in conjugation with this double bond. Conjugation means two things separated by single bond. Okay, if two double bonds are separated by single bond, then two double bonds are in conjugation. Sir, if double bond is separated by single bond with the lone pair, then we can say lone pair is in conjugation with the double bond. Here between double bond and lone pair, if single bond is there, then we can say double bond is in conjugation with the lone pair, we can say. Then now it is unsaturation, it is also unsaturation. If two unsaturated groups are separated by a single bond, then they are in conjugation, then they will go for resonance. Okay, now we will take double bond separated by single bond with the positive charge. Now positive charge is unsaturation, double bond is unsaturation. These two unsaturated groups are separated by single bond, then we can say double bond is in conjugation with the positive charge. Then double bond and positive charge will go for resonance. Then we will take a double bond with a negative charge. We will take double bond and negative charge are separated by single bond. So double bond is in conjugation with a negative charge. So if conjugation is there, resonance is possible. Resonance means what? Migration of electron cloud. That's all. Migration of electron cloud from one place to another place. That is called resonance, we can say. Now in iodobenzene, resonance is possible. Why? Because here lone pair is there, here double bond is there. Double bond and lone pair separated by a single bond. So lone pair is in conjugation with this double bond. So resonance is possible. Resonance means migration of electron cloud. Set. So now iodine is having 3 lone pairs. It is connected to, it is bonded with benzene. Bonded with benzene. Here we can say resonance is possible, we can say. Now lone pair is coming to this place, this pi bond is moving to this place, so we are getting iodine. Now iodine is having 2 lone pairs. Since it has donated, it is getting positive charge. Here double bond, then we will give, here negative charge we will give, here lone pair will give, here 2 pi bonds will give. Next resonance structure will continue. We are continuing resonance structure. Here double bond we have given. Now, how the resonance structure is possible in the sense, this lone pair becomes pi bond becomes lone pair. So here 2 pi bonds we can give, here lone pair with a negative charge we can give, iodine is having positive charge. Next resonance structure will take, iodine is having 2 lone pairs and double bond. Now here we will take phenyl ring. Now migration of charges we will give, migration in the sense this lone pair becomes pi bond becomes lone pair. So here 2 pi bonds are there. Here lone pair we will say, here negative charge we will give to this carbon. For this iodine we have given positive charge. Okay. Now resonance is possible. These 4 are resonance structures. Resonance structures are separated by double-headed arrow marks. Okay. Now we will see resonance hybrid. We will see resonance hybrid is the actual structure of a molecule. So how the resonance hybrid will be there, that we will see. In the resonance hybrid we have given all the single bonds we have given. Now we will see regarding pi bond. At this place pi bond is present, at this place pi bond is not present. Sir, so how what to do in the sense, we will do one thing, this in to all the carbon atoms we will give pi bond, and at this place single bond is there, but here double bond is there. So here also we will give pi bonding, we will give, because these 3 resonance structures are having pi bond between carbon and iodine. So let us do one thing, this pi bonds how many are there, we'll see. Totally 3 pi bonds, and this one lone pair, totally 8 electrons are delocalized. The delocalized electrons we will give like this. The delocalized electrons we will give like this. delocalized electrons. Due to this delocalization, what happens means this carbon is getting negative charge, this carbon is getting negative charge, this carbon is getting negative charge. So negative charge is there in the phenyl ring. So for phenyl ring, we will give negative charge. We will give negative charge. We are given to phenyl ring. For phenyl ring, we will give negative charge. For iodine, we will give positive charge. So like this, we have given. So in this resonance hybrid, we can say here what is there means partial double bond is there. Partial double bond is there, we can say. So between carbon and iodine, partial double bond is present. So resonance hybrid says between carbon and iodine, partial double bond is there. So now we will say, so here in here, what is the bond in the sense partial double bond? We can say here what bond is there means partial double bond is there. Because of partial double bond, this nitrogen is attacking, but this bond is not shifting. Therefore, only it is not going for nucleophilic substitution. So, due to partial double bond, this nitrogen, though nitrogen is attacking this carbon, this bond is not shifting. Therefore, it is not going for nucleophilic substitution reaction because of a partial double bond between carbon and iodine, we can say. Sir. So now we can say this iodobenzene, that means aryl halide. Aryl halide means halogen is directly attached to phenyl carbon. So aryl halides do not undergo nucleophilic substitution reaction because of partial double bond. Okay. So this is general. Exception is there. Aryl halides also can undergo nucleophilic substitution reaction in exception cases. That means, for example, with this reagent, here NH2 minus is the nucleophile. If this nucleophile comes, then this nucleophile will replace. That is replaced. Okay, we will see regarding this later. Now, what is the conclusion in the sense? Aryl halides do not undergo nucleophilic substitution reaction. Okay. So aryl halides do not undergo this nucleophilic substitution reaction. Now we will see regarding this alkyl halide. Alkyl halide means this nitrogen. This nitrogen should attack this carbon. Then this bond is shifting. How here single bond is there? Like this single bond is there here. Here resonance is not possible between iodine and phenyl. Between iodine and phenyl, no resonance because two single bonds are there, therefore no conjugation, so no resonance. So between this carbon and iodine, single bond, therefore this is undergoing nucleophilic substitution. Okay, so that in this nucleophilic substitution, this aryl halide is not undergoing nucleophilic substitution. Sir, okay. Next we will take next reaction. We will see. We will take haloalkane. This Ri we will take. To this we will add NaNO2. Here what is the solvent? Solvent is alcohol. What is the product? One product is a nitro compound. We are getting. Another product is what means nitrite compound we are getting. Which is major and which is minor means this nitro compound is minor. This nitrite is a major. This nitrite is major in this case. Sir, why is it so? That we will see. Now we will take this NaNO2. We will take NaNO2. We can write it as Na plus NO2 minus. Remember that alkali metals will form ionic compounds. So sodium is alkali metal. So this compound is ionic compound. So between sodium and NO2, plus and minus is there. Between Na plus and NO2 minus, ionic bond is present. Sir, it is ionic compound. Now NO2 minus will take. NO2 minus we can write like this. Now this negative charge we will give to this oxygen. Oxygen comes under 6th group. So this valence shell is containing 6 electrons because of minus 1 electron. Nitrogen comes under 5th group. So this valence shell contains 5 electrons. Those 5 electrons we have given. Oxygen comes under 6A group. So 6 electrons present in the valence shell, like this we have given. Due to lone pair in this nitrogen, this NO2 minus is having bent shape. Okay. So now so and so is there. Now we will take Ri. We will take Ri. We will take now this O minus is attacking this R. I minus is leaving. Therefore, we will get what compound in the sense RONO, like this compound we will get. Here, what is a nucleophilic site in the sense O is a nucleophilic site. Here, donor is oxygen. Therefore, we got a nitrite. We got. Set. What is another possibility? We'll see. Another possibility we'll see. We'll take Ri. If nitrogen lone pair is attacking this bond is shifting, then we will get what in the sense RNO2. RNO2 will get. This compound will get, nitro compound will get. So here we got what in the sense nitro compound we got in this nitro compound. We got a nitro compound here. Here, if you see, nitrogen is the attacking site, nitrogen is the donor, nitrogen is acting as a nucleophilic center. Okay, this nitrogen is acted as a nucleophilic center. We got this nitro compound. Now we will take this nitrogen and oxygen, which is having higher nucleophilicity, in this case. What experimental result says? Experimental result says that it is a major compound, it is a minor compound. Experimental result says it is major, it is minor. So as per experiment, this O minus is having higher nucleophilicity. O minus is having higher nucleophilicity. This N is having lower nucleophilicity. O minus is having higher nucleophilicity. N is having lower nucleophilicity as per the experiment. So experimental analysis says that it is major compound, it is minor compound. So as per experiment, we can say O minus is having higher nucleophilicity, N is having lower nucleophilicity. Here we cannot consider electronegativity of oxygen and nitrogen. We can't explain using electronegativity of oxygen and nitrogen. We cannot explain. So we can explain only with respect to what means it is O minus, whereas it is N. Because of minus charge, it is having higher nucleophilicity than nitrogen. That explanation only we can give. We can't give explanation in any other way. Okay, sir. So we came to know this O minus is having higher nucleophilicity from the experimental result because it is major product. Okay, so don't explain this one with the electronegativity. With the electronegativity, we cannot explain. Okay, sir. So if you take NaNO2, what is a major product in the sense this is the major product? Sir, in the place of Ri, what can be there? Okay, in the place of R, you can take alkyl. We cannot take aryl halide. Aryl halide we cannot take. The reason is same like previous case. Okay, we can take R-alkyl halide. We can take R-alkyl halide. We can take. Okay, therefore this can go for this nucleophilic substitution. This can go for this nucleophilic substitution, whereas aryl halide do not undergo this nucleophilic substitution. Side. Now we will go to conclusion. So Ri with AgNO2. AgNO2, if we take, what is a major product means RNO2 is the major product. It is a major product. What is the minor product in the sense RONO is the minor product in this case. Okay. Next, this Ri plus NaNO2 will take. NaNO2 will take. We are taking NaNO2. We are taking here. What is a major product in the sense major product is RONO. RONO is the major product. This RNO2 is the minor product here. Why is it so? Okay. So conclusive result says that here covalent bond is present. Here covalent bond is present. Therefore, this nitrogen is having higher nucleophilicity. This nitrogen is having higher nucleophilicity. So nitrogen is attacking this R. So nitro compound is a major. Now here if you see, this bond is a ionic bond. This bond is ionic bond. Therefore, this O minus is having higher nucleophilicity. This O minus is having higher nucleophilicity. Therefore, this RONO, this nitrite is major here. Okay. So remember that if you want nitrite as major product, take NaNO2. If you want RNO2 as a major product, take AgONO. AgNO2, take it. AgNO2, you take it. Sir, okay. Next, suppose we want to take what in the sense NaNO2 only we want to take. But this should be the major. What to do? Now what we want to do in the sense, we want to go against experiment. That what is against experiment means, Ra we will take NaNO2 we will take, and what we will do in the sense, we will get the products like this, we will get the products like this, but we want to make this is as a major and this is as a minor. We want to make it like this. So we want to make this is as a major means, what we have to do, we have to make Na either Na plus O minus NO2, isn't it? Like this is there. We want to make this nucleophilicity high. We want to make this nucleophilicity high. Then only this is major, no? Okay. So we are going against experiment. Okay. Now we want to make this is as a major. So we want to make this as a higher nucleophilicity. So simple. How to make this as higher nucleophilicity? Reduce ionic nature here. That's all. Reduce ionic nature. You go on reduce ionic nature here, then automatically this nucleophilicity will go on rise. Then automatically this will become major. That's all. So, how to reduce ionic nature here? How to reduce ionic nature? You will take solvent here, lower the polarity of solvent. You go on lower the polarity of solvent, automatically this ionic nature goes on reducing, then this nucleophilicity rising, then it will become major product. That's all. Sir. So here polarity of solvent. Sir, what we have to do means, we have to take low polar solvent we have to take. So what is a low polar solvent? Which is the low polar solvent? That we will see. Okay. So polar solvent to polarity. Here polarity how should be there means, polarity should be less. Polarity should be less. Sir, to take lower polarity, what we will take in the sense, DMF we will take. DMF in the sense, dimethyl formamide. Dimethyl formamide we will take. Sir, first we will take formic acid. We will take formic acid formula is HCOOH. It is formic acid. Now we will treat this with ammonia. We will treat this with ammonia. Ammonia we will take ammonia we will write like this. Now formic acid and ammonia are reacting. Therefore, what is leaving in the sense, water is leaving. So what we will get in the sense, HCONH2. Now see, C double bond O and N in the sense it is amide. This amide is obtained from formic acid. So take form and write amide. So what is this? Formamide. Now we want dimethyl. So make this is as a methyl group and make this is as a methyl group. So dimethyl formamide. So we got dimethyl formamide. This dimethyl formamide is having lower polarity. This dimethyl formamide, if you take, what will happen means, in NaNO2 ionic nature reduces. Why is it so? This dimethyl formamide, if you take, here ionic nature is reducing, then this nucleophilicity rising. Why is, how it is possible, that we will see. So now we will take a dimethyl formamide CO group NH2 is there. Now we will take like this. So for this, how the dipole will be there? It is a polar solvent, no doubt. How the polarity will be there? If you see, for this dipole moment like this, for this dipole moment like this. So net dipole moment, if you see how it will be there means, it will have partial negative charge. It is also having partial negative charge, but for this partial negative charge is more when compared to this. Therefore, we will give negative charge here, and here we will give positive charge. So we will give dipole is how in the sense, here partial negative, here partial positive. It is the dipole. So now this dipole is to this we will add NaNO2. Okay, to this solvent we are adding NaNO2. Now NaNO2 is splitting, Na plus NO2 minus, it is splitting because of this minus charge is pulling Na plus. Therefore, Na plus is getting solvated. Na plus is getting solvated, we can say. Na plus is getting solvated like this. because solvent is what? DMF is a solvent. Now Na plus is getting a solvated like this. Sir. Now here positive charge for this carbon, this positive charge is attracting this NO2 minus. Sir, we will take a, so we will take like this. We will take like this. We will take here. What is that? Means O minus N double bond O is there. Okay. Now we will take another one. Another one like this. We will take solvent. Now this anion is not solvated easily because positive charge is inside. This anion is not solvated easily, but cation is solvated easily. So that since anion is not solvated easily, this anion is along with Na plus only. Therefore, between this positive charge and negative charge, neutralization takes place. Therefore, here covalent nature is rising. You know one thing, like dissolves like polar substance dissolves in polar solvent, but this is having lower polarity because here bulkiness is there. Due to bulkiness, anion is not solvated. So anion is not solvated. Therefore, this solvent is not solvating. This solvent is not solvating anion completely. Therefore, what happens here between them, ionic nature is reducing. Like dissolves like. If solvent is easily solvating this, then ionic nature will be rising. Ionic nature rising means they are getting separating. If they are not separating, they are coming closer and closer, in the sense plus charge will be cancelled by negative charge. Then covalent nature is rising. Okay, we will take another solvent. Dimethyl sulfoxide we will take. DMSO. This is what means dimethyl sulfoxide. Dimethyl sulfoxide. Okay, sulfoxide will take S double bond O, so methyl and methyl. So here we can say here partial charge, negative charge. Let us add NaNO2. Now Na plus will be solvated by O minus. Okay, what about NO2 minus? NO2 minus will take like this. Okay, so to solvate NO2 minus, what group should come closer means this sulfur should come closer. Sulfur is coming closer. Okay, so sulfur is coming closer like this. So when sulfur is coming closer, what happens means, so sulfur is surrounding this NO2 minus, but methyl groups are there. Because of bulkiness of methyl groups, steric hindrance takes place. Due to steric hindrance, this anion is not solvated properly by this solvent. So this solvent is not solvating this anion. Not solvating means this anion will be with Na plus. So with Na plus means positive charge and negative charge getting cancelling. Therefore, here covalent nature is rising. So this here ionic nature is reduced. So due to this solvent, ionic nature is reduced. Therefore, what will happen? So now we will see. We are taking the solvent such that we will take DMF, we will take dimethyl formamide. Otherwise, we will take DMSO, dimethyl sulfoxide. We will take. Because of this solvent, anion is not solvating properly. Therefore, here these two, this cation and this anion is not splitting. Therefore, ionic nature is reducing. So nucleophilicity of N is rising. Therefore, it is becoming major, whereas it is becoming minor. So that if we want to make reverse, actually if we take NaNO2, RONO is the major. Wantedly, if you want to make RNO2 is the major, if you want this as a major, then take solvent DMF or DMSO you take, then what will happen means you will get reverse, you will get. Sir, okay. Next, we'll see, we'll take this Ri. To this, we will take NaNO2. What is the product in the sense nucleophilic substitution is the product. Nucleophilic substitution is the product. Nucleophilic substitution is possible. Sir, okay. So in the place of R, we will take suppose CH3, CH2, I. So what is happening means this NO2 minus is attacking this carbon. Okay, suppose we will take like this. This O minus is attacking this carbon. This bond is migrating. So we will get the product is what in the sense nucleophilic substitution product we will get. This is the product we are getting as a major. Now we will take here we'll take here so and so compound will take. We are taking a now so and so compound will take. It is this iodine is attached to primary carbon, therefore it is primary alkyl halide. This iodine is attached to secondary carbon, therefore it is secondary alkyl halide. Now what will happen means we will add this NO2 minus. So this O minus is attacking this carbon, this I is leaving, so the product is CH3 CHONO, then this CH3 we can say. So this is a product we can say. Okay. Next, what is another product here? What is there any other possibility? Is there any other possibility here? That point we will see. Now, this O minus, in this O minus is abstracting this proton. It is abstracting proton means it is acting as a base. Then this bond is shifting, so we will get the product is CH3, CH double bond, CH2. It is called elimination product. It is called what means elimination product. It is called what means substitution product. So we got substitution product as well as elimination product. Generally, this elimination product is dominating for which case in the sense of secondary and tertiary alkyl halides it is dominating. Okay, so this elimination product is dominating for which case means secondary and tertiary alkyl halides means elimination product will dominate. Substitution product will dominate for which case in the sense primary alkyl halides. Okay, so generally primary alkyl halides if we take, substitution product is dominating. Secondary and tertiary alkyl halides if we take elimination product will dominate. We can make even this primary alkyl halide also can give elimination product as the dominant when if you rise the temperature. Primary alkyl halide also will give elimination product as major if you take higher temperature. Otherwise, substitution product will be dominating. Secondary and tertiary if you take, elimination product is dominating when compared to substitution product. Okay, therefore in this case, in this reaction, if you want nucleophilic substitution reaction, you take a primary alkyl halide you take. Okay, if you want a nucleophilic substitution, if you want a nucleophilic substitution reaction, you take primary alkyl halide you take instead of taking secondary and tertiary. If you take secondary and tertiary, if you take elimination product will dominate. Okay, so conclusion is, so nucleophilic substitution if you want take primary. If you want elimination product, you take secondary and tertiary. Sir, we are taking primary, but we want elimination means I take high temperature. Okay, so like this you have to go for the conclusion. Sir, okay. So what is the conclusion? What is the conclusion now? Conclusion in the sense this Ri with AgNO2 if you take, nitro compound is the major. Ri with NaNO2 if you take, nitrite is the major. Sorry. Aryl halides will not go for this nucleophilic substitution. Remaining halides will go for nucleophilic substitution. In this also, primary if you take, primary halides if you take, nucleophilic substitution possible. Secondary and tertiary halides if you take, elimination is possible. Okay, so let us complete the class. We will continue tomorrow.